Okay, let's talk a little bit about measurement and congruence. Now, especially in geometry, the idea of measurement is important because we have a lot of different kinds of units. When I say units, I don't necessarily mean like meters and feet and inches, okay, although those are different kinds of units. What I mean is, because there are different kinds of objects that have to be measured, we actually have different types of measurement. What we've looked at so far with lines and line segments and rays, especially line segments, we see this letter M, and this says the measure of line segment AB is 5. So from here to here is 5. Now we call that in measuring between 2 points, we call that distance. So measurement, one of the kinds of measurement is distance. Distance is a measurement used for one dimension. It is a measurement unit of one dimension, okay? And so distance is a numerical value that represents how far a distance between 2 points. So the distance between A and B, the distance between B and C here is 4. The distance between C and D is 6. And we learned with the segment addition postulate that we can also measure the distance between A and D by knowing the distance from A to B, B to C, and C to D. All we do is add up the 3 separate measurements, 5 plus 4 plus 6, and that gives us 15. So now the distance between A and D is 15, okay? So when dealing with one dimension, with lines, line segments, and rays and that sort of thing, distances between 2 points are a measurement of distance. That's going to be different when we talk about area, when we talk about volume, and when we talk about angles. We don't measure in distance, we actually measure in other kinds of units, okay? So now let's talk briefly about congruence. In a lot of math, we use the word equals, right? Like 4 is equal to 4, and 2 is equal to 1 plus 1, and 7 is equal to 9 minus 2, okay? And this is an idea of value. We're saying the value of 7 is the same thing, equal to the value of 9 when you take away a value of 2, okay? But in geometry, we use a different word generally than equals. Like we can say that 9, the distance between D and E, 9 is equal to the measure of A to B plus the measure of B to C. Those are equal. But when we speak of the objects themselves, we use the word congruence. And congruence uses this symbol. It's an equal sign with a little squiggly thing on top of it. And congruence means same size, same shape, okay? And so what we're going to do right now is I'm going to show you a couple of examples of congruence. So here's a quick example. Here we have segment AC, and here we have segment DE. We know that the measure of segment DE is 9, because it says it right here. But the measure of segment AC is equal to the measure of AB plus the measure of BC, because of the segment addition postulate. And that's going to be 5 plus 4. 5 plus 4, which is 9, which is equal to the measure of DE. So the measures are equal. But what we would say is that the segment itself, segment AC, is congruent to segment DE. Why? Because it's the same size, 9, and it's the same shape, segment. Okay? So we would say this segment AC is congruent to segment DE. Let me show you another example. Okay, so now let's consider 2 line segments on the coordinate plane. This is the segment PQ. This is the segment FG. we need to know their measurements. They're both line segments, so they're the same shape. Now we just need to know if they are the same size. Okay, well, P is at the coordinate 2, 4. Q is at the coordinate 5, 9. F is at the coordinate 4, 3. G is at the coordinate 9, 6. This is enough information to find the distance of the segment. Okay, remember, it's a measurement, distance. So, the distance formula is the square root of the sum of the squares of the differences of the coordinates. So, x minus x, y minus y. All right, so here we have x minus x, 5 minus 2 squared. That's 3 squared, 9. 9 minus 4 is 5 squared, that's 25. 25 plus 9 is 34. So the measure of segment PQ is the square root of 34. Measure of segment FG is the same. We have the x's, 9 minus 4 squared, that's 5 squared is 25. 6 minus 3 is 3, squared is 9, 25 plus 9 is 34, square root of 34. So the measure of segment PQ is equal to the measure of FG, therefore they are the same size, same shape, same size. Segment PQ is congruent to segment FG.